The anomaly presents as a slow leak. At 2:14 a.m. on March 18th, the crew chief completing a pre-launch inspection of Bureau number 166847, an A-18E, assigned to the third section of Wave 7's deep strike package, finds a hydraulic fluid sheen on the lower surface of the left main landing gear bay that was not present during the previous inspection 4 hours ago. The sheen is light, not a drip, not a stream, a seep, the kind of micro-leakage that can come from a dozen sources in a complex hydraulic system, and that the maintenance community distinguishes carefully from a structural failure. The crew chief photographs it, logs it, and calls the aircraft's plane captain. Together, they trace the seep to the left main landing gear actuator's primary seal assembly, a component that was replaced 8 days ago on March 10th as part of a scheduled 200 flight-hour maintenance cycle. The replacement was completed by the carrier's aviation hydraulics maintenance team, using parts drawn from the ship's aviation consumables inventory. The work was signed off by the division's quality assurance officer. The aircraft was returned to the flight schedule the same day. The crew chief logs the seep as a hydraulic system discrepancy and removes Bureau number 166847 from the Wave 7 launch sequence. A replacement aircraft is positioned on the deck. Wave 7 launches on schedule at 2:30 a.m. At 3:47 a.m., Bureau number 166847 is in the hangar bay, being worked by the hydraulics maintenance team. They have removed the left main landing gear actuator's primary seal assembly and are inspecting the component. The lead hydraulics technician has been working on A-18 hydraulic systems for 9 years. He has replaced hundreds of seal assemblies. He has seen seal failures from manufacturing defects, installation errors, contamination, and normal wear. What he is looking at in the seal assembly removed from Bureau number 166847 is something he has not seen before in a component that was installed 8 days ago. The seal's primary elastomeric element, the rubber compound ring that provides the pressure boundary between the actuator's hydraulic fluid volume and the external environment, shows compression set characteristics consistent with a component that has been in service for 18 to 24 months, not 8 days. The rubber has deformed under load in a way that takes time to develop. The seal dimensions, specifically the cross-sectional geometry that determines how effectively it maintains contact pressure against the actuator housing bore, are outside the tolerances specified in the Boeing maintenance manual for a serviceable seal. Not by much, a fraction of a millimeter in the cross-section diameter. But a fraction of a millimeter in a hydraulic seal operating at 3,000 pounds per square inch determines whether the seal holds or seeps. And this seal is seeping because its rubber compound has aged in a way that an 8-day-old seal should not have aged. The technician bags the component and marks it for quality assurance review. He installs a replacement seal from the ship's inventory. He looks at the part number on the packaging for the new seal. It matches the part number on the packaging for the old seal. He looks more carefully at both packages. They look identical. Same part number, same manufacturer's lot code, same installation date. He puts the old seal's packaging on the workbench and looks at the new seal's packaging for 30 seconds, comparing them. Then he calls the division's quality assurance officer. The quality assurance officer arrives in the hangar bay at 4:10 a.m. He examines both packages. He examines both seals. The packaging is identical. The seals are not. The removed seal is manufactured from a rubber compound that does not match the specification for this part number. The color shade is marginally different. The surface texture is slightly coarser, and the dimensional measurements are within tolerance, but at the boundary. The replacement seal from the new package has the same characteristics. Both components are dimensionally acceptable. Both have the correct part number. Both came from the ship's inventory. The ship's inventory came from the naval aviation supply chain. At 4:25 a.m., the quality assurance officer has requested a full inspection of every hydraulic seal assembly in the FA-18's 200 flight hour maintenance parts inventory, the lot of components that were drawn from supply to support the March 10th maintenance cycle that produced the seal now on the workbench. The inventory inspection reveals 34 seal assemblies in stock. All 34 are from the same manufacturer lot code that produced the installed component. The quality assurance officer draws 3 seals at random from the 34 and sends them to the ship's materials laboratory for dimensional and compound analysis. He then pulls the installation records for the March 10th maintenance cycle to determine how many seal assemblies from this lot were installed on aircraft during that cycle. The answer is 11. 11F/A-18S received hydraulic seal assemblies from the same lot code during the March 10th 200 flight hour maintenance cycle. Those 11 aircraft have been flying combat missions for 8 days. The SEEP on Bureau number 166847 is the first indication that anything is wrong. But the seal's compression set characteristics suggest the failure mode was not triggered by an acute event. It was progressing since installation, and it presented on this particular aircraft on this particular night because the cumulative load cycles and operating temperature excursions over 8 days of sustained combat operations crossed the threshold at which a marginally undersized seal begins to leak at operating pressure. If the threshold varies across the 11 aircraft according to their individual operational profiles, the other 10 seals may be at different points in the same progression toward the same failure mode. The Wave 7 aircraft are still airborne over Iran when the quality assurance officer makes the call that will change the morning's maintenance priorities. He contacts the maintenance control officer at 4:47 a.m. 11 aircraft, hydraulic seal inspection required on recovery, all from the March 10th maintenance cycle lot. The maintenance control officer pulls up the flight schedule. Of the 11 aircraft with seals from the suspect lot, 7 are currently airborne in Wave 7's strike package. 4 are on deck in various maintenance states. The 4 deck aircraft are taken off the flight schedule immediately. The 7 airborne aircraft are flagged for post-recovery priority inspection. They will be pulled from the Wave 8 planning cycle until their hydraulic systems are checked. The pilots of those 7 aircraft are not told anything specific. The maintenance control officer consults with the Air Wing commander, and the Air Wing commander makes the operational decision that is the hardest decision he will make this morning. The 7 aircraft continue their mission profiles, telling them now, over a communication channel that cannot be fully secured against electronic collection, that their hydraulic systems may have a developing failure mode would either compromise the communication architecture or generate a tactical disruption, aircraft aborting missions or modifying their profiles that cannot be hidden from threat collection assets monitoring the air operation. The hydraulic seep on Bureau number 166847 manifested as a ground-level micro-leak, not as an in-flight failure. The seals have been in service for 8 days, and 6 of the 7 aircraft have completed multiple previous missions without hydraulic anomalies. The Air Wing commander assesses, continue the mission, inspect on recovery. The 7 aircraft fly their profiles. The Wave 7 aircraft are still airborne over Iran when the maintenance control officer makes the call at 4:47 a.m. to flag all 7 airborne aircraft for post-recovery priority inspection. The Air Wing commander is briefed immediately. He has the fuel states and mission profiles for all 7 aircraft, and he has the hydraulics team's preliminary assessment. The seal failure mode is a slow progression, not an acute event. Bureau number 166847's seal had been developing its leak for 8 days before it presented as a visible seep during a ground inspection. The failure mode doesn't accelerate suddenly. It progresses under load cycling and temperature variation, the operational conditions that 8 days of sustained combat flying produce. The Air Wing commander consults with the ship's maintenance officer for 6 minutes. The maintenance officer's assessment is that the probability of an in-flight hydraulic emergency on any of the 7 aircraft during the remaining mission time, measured in hours of accumulated load cycles against the failure progression rate, is low, but not negligible. It is not low enough to be ignored, and not high enough to justify compromising the mission and the communications architecture to notify the airborne crews. The airborne crews are not told. They continue their profiles. The Air Wing commander will carry that decision in the post-mission debrief and in every review of the incident that follows, and the calculus is neither comfortable nor clearly wrong. It is the kind of operational decision that command authority exists to make, and that no training scenario fully prepares a person to execute with equanimity. He makes it. The aircraft fly. The aircraft return. 2 of the 7 aircraft have minor hydraulic quantity losses on recovery. Both pilots notice a soft feel in their flight controls on final approach, a subtle reduction in control authority that both men attribute, in the moment, to possible air data system variation or mild turbulence in the ship's wake. Neither declares an emergency. Both land. Both log the control feel anomaly in their post-mission debrief notes with the professional understatement that combat aviators apply to events that fell within operational bounds. Noted slight control feel variation on final monitoring. The hydraulic system inspections conducted on both aircraft confirm that the soft feel was hydraulic quantity loss from seal degradation, and that both aircraft were within operational limits for recovery, and that both pilots' logged notes were accurate and appropriately measured. The Air Wing commander reads those debrief notes at 9 a.m. when the full inspection results are compiled. He marks them for the safety review. He adds nothing to them. The notes say what happened. What happened held within limits. The limits were the product of 8 days of accumulated load cycling against a seal failure mode that progressed at exactly the rate the maintenance officer's assessment predicted. The assessment was right. The decision was made with the right information. The 7 aircraft returned. The record reflects all of this without additional commentary, because additional commentary would imply that the decision could have been made differently, and the Air Wing commander is not certain that it could have been made differently with the information available at 4:47 a.m. on March 18th, 7 hours into a combat operation that could not be recalled without consequences that exceeded the risks of continuing. The materials laboratory analysis of the 3 seals, the quality assurance officer sent for testing, returns at 7:45 a.m. The analysis confirms what the lead hydraulics technician's visual and tactile assessment suggested. The rubber compound in the seals is not the specification compound for this part number. The seals are made from a lower-grade elastomeric formulation that is dimensionally compatible with the design specification and will pass an incoming inspection that checks part numbers and dimensions. It will not pass an incoming inspection that includes compound analysis because the compound is not the right compound. Under sustained high-pressure cycling and temperature variation, the operational conditions of a combat aircraft conducting multiple daily sorties, the lower-grade compound degrades faster than the specification compound. Its compression set characteristics develop over weeks instead of months. Its pressure boundary integrity erodes over operational time in a way that the specification compound would not exhibit until many times longer in service. The parts are counterfeits. They were manufactured to look like the correct parts. They carry the correct part numbers. Their dimensions are within tolerance. Their packaging matches the genuine manufacturer's packaging with sufficient fidelity to pass visual inspection. They will fail in operational service faster than genuine parts. They were introduced into the naval aviation supply chain at a point upstream of the carrier's inventory, and they arrived on the ship's shelves as part of a routine supply replenishment transfer that the ship's incoming inspection process accepted, because the parts checked out on every parameter the incoming inspection examines. The investigation of how the counterfeit seals entered the supply chain begins at the carrier's supply officer's office at 8:30 a.m. and traces backward through the logistics record with the support of the Naval Supply Systems Command's Quality Assurance Team, which is notified at 9 a.m. and activates its counterfeit parts response protocol. The carrier's hydraulic seal inventory was replenished from a shore-based aviation parts warehouse on March 7th, 3 days before the March 10th maintenance cycle that distributed the suspect parts to 11 aircraft. The March 7th transfer was a standard resupply of consumables, including seal assemblies, packaged in manufacturer lots. The warehouse's own inventory records trace the specific lot code to a receipt from an authorized distributor on February 28th, 2 days before Epic Fury began, and 3 days before the carrier left its pre-deployment anchorage for its current operational position. The authorized distributor that supplied the lot to the warehouse is a naval aviation parts supplier with a long-term contract and an established delivery relationship. Its incoming quality inspection process includes dimensional checking and part number verification. It does not include rubber compound analysis because compound analysis requires laboratory equipment that the distributor's receiving inspection does not possess, and that the specification standards for receiving inspection do not require. The lot that arrived at the distributor on February 23rd, 5 days before Epic Fury, and 5 days before the distributor transferred it to the naval warehouse, carries a certificate of conformance from the manufacturer stating that the parts meet all applicable specifications. The certificate of conformance is fraudulent. The manufacturer lot was not produced by the named manufacturer. It was produced by a facility that can replicate the dimensional specifications, the packaging, and the conformance certification of genuine parts, but cannot or does not replicate the rubber compound formulation. The production facility is not identified in the Navy's supply chain records because it is not in the Navy's supply chain. It inserted its product into the chain through a counterfeit lot that was substituted somewhere between the named manufacturer's production output and the distributor's incoming dock. The substitution point, the specific node in the distribution network where genuine parts were replaced with counterfeits, is the focal point of the counterintelligence investigation that will run for 6 weeks following the carrier's discovery. What the 6-week investigation finds is a logistics broker operating between the manufacturer and the authorized distributor, a small company in a mid-tier distribution tier that acts as an intermediary inventory manager for multiple aerospace parts categories. The broker received a genuine lot from the manufacturer on February 18th. On February 19th, the broker transferred a lot to the distributor that carried the same lot code as the genuine receipt, but contained different parts. The genuine parts from the February 18th receipt are not in the broker's inventory on February 19th. They were removed and replaced in a 24-hour window. The person with access to the broker's inventory on the night of February 18th to 19th is a logistics coordinator who has been with the firm for 14 months. His financial records show payments from the same IRGC-linked financial infrastructure that appears in the other cases from this campaign's counterintelligence record. Cryptocurrency routing, Bahraini exchange, domestic cash account, total received over 9 months $67,000. His first payment preceded his employment at the logistics broker by 3 weeks. He was funded before he started. The broker position was the operational target, and he was placed in it with the specific purpose of having access to naval aviation parts inventory at the distribution tier, the most upstream accessible point in the supply chain above the end user. At the tier below the manufacturer, above the authorized distributor, in the 24-hour transit window between receipt and transfer, 34 seal assemblies for F/A-18 hydraulic systems were replaced with counterfeits. He is in New Jersey when the investigation reaches him. He is taken into custody by NCIS and FBI personnel at 11:30 a.m. on March 19th, 6 days after the carrier's hydraulics team found the compression set anomaly in the hangar bay. His home workspace contains a secondary laptop with a cryptocurrency wallet interface and a document directory containing conformance certificate templates for 7 additional part numbers in naval aviation consumable categories. He had not yet had the opportunity to use them. The classified after-action documentation records the following: 11 EF-18Es with counterfeit hydraulic seal assemblies installed during the March 10th maintenance cycle. 7 of those aircraft airborne over Iran during Wave 7 when the discovery was made. 2 aircraft with minor hydraulic anomalies on recovery. All 11 removed from the flight schedule for 22 hours pending seal replacement. 0 in-flight hydraulic emergencies. 0 aircraft lost. The operational cost of the 11 aircraft's temporary removal from the schedule. Wave 8 restructured around a reduced strike element, 2 target nodes held for Wave 9, and a campaign timeline extension of approximately 18 hours. 1 logistics coordinator in custody in New Jersey. $67,000 across 9 payments over 9 months. A secondary laptop with certificate templates for 7 additional part categories. 1 24-hour window on the night of February 18th to 19th, in which 34 seal assemblies passed through a distribution node and came out different. The supply chain that feeds a carrier's maintenance operation extends from the ship's tool room backward, through a warehouse, through a distributor, through a broker, through a manufacturer, and through every logistics node that connects each of those points. At any node where inventory transits in bulk and the receiving inspection checks dimensions and part numbers, but not compound formulation, an adversary with access to the node and knowledge of the incoming inspection's scope can substitute a part that looks correct for a part that is correct. The substituted part will fly. It will pass every inspection that does not include the specific test that would reveal the substitution. It will perform correctly for a period of time, determined by the difference in degradation rate between the genuine and counterfeit material. And then, at a point determined by load cycles and temperature history and the specific operational profile of each individual aircraft, the failure mode will present. Slowly enough that no single failure is catastrophic. Systematically enough that when the pattern appears, the investigation traces directly to a 24-hour window on February 18th and a logistics coordinator who had been waiting, funded and in place, for exactly that window. The carrier's hydraulic seal inventory was audited and cleared within 72 hours of the discovery. The incoming inspection protocol for hydraulic seals and 11 other safety-critical elastomeric part categories was revised to include compound analysis sampling on all lots received from the distribution tier going forward. The revision adds 4 hours to the incoming inspection timeline for affected parts and requires laboratory capability that the carrier's supply department does not currently have. The analysis is conducted at depot level, which means a 72-hour delay between receipt and availability for use. The 72-hour delay is accepted. It is the cost of knowing that what you installed on the aircraft is what you believe you installed. The lead hydraulics technician who flagged the anomaly at 4:10 a.m. was doing what his training and his 9 years of experience taught him to do. Look at the part, not just the paperwork. He saw something in the compression set characteristics that was wrong for an 8-day-old component. He called it. The investigation that followed resolved in 6 weeks. The modification that followed resolved in 72 hours. The part that was installed on Bureau Number 1, 668,478 days. Before the discovery had been working its way toward that seal failure in the hydraulic system of a combat aircraft flying missions over Iran. Since the moment it was installed from an inventory that didn't know it was compromised. The difference between a hydraulic seal that meets specification and one that almost meets specification is measurable in fractions of a millimeter and in the molecular structure of a rubber compound. At 3,000 pounds per square inch in a main landing gear actuator on an aircraft pulling 7G over the Zagros Mountains at night, that fraction and that molecule are the entire margin between a functioning aircraft and one that is developing a failure that its crew cannot yet feel.